Yo, what's up, guys? Welcome. My name is Angel, and this is a new channel. Sorry if I'm not looking at you a lot. My screen's up here, and the camera's down here. But, anyways, I just want to introduce myself and tell you a little bit about this channel, what it's going to be about, and then we'll jump straight into the tutorial. So, the idea behind this channel is to offer you projects that you can do or improve as you learn different programming languages. My main focus will be in Python. I also want to offer you realness and transparency in tech from my experience and from hopefully interviews that I'll have with other people. So stay tuned for that. I also want to give you advice from my perspective as a first generation college student who went on to grad school after a couple hard years, and other life tips from my point of view. I want to keep this authentic, positive, and enjoyable. Feel free to shoot me a DM through Twitter or leave me a comment down below on some things you'd like to see, have me talk about, have me review, and whatnot. But jumping straight into it, today we're going to implement a rock, paper, scissors game in Python. This will be a command line interface project, so make sure you know how to use your terminal or your command prompt. It will be a basic project that you can then improve on your own time for your own use, for school, or just for fun. I'll give you some examples at the end of this tutorial of what else you can do, but today we're just sticking with the basics and we're having fun and learning. You can follow along by clicking on a My Binder link in the description. This will open up a web browser with jupyter-notebook where you can have fun, play around with what we're doing today, or you can also access all the content for today on my GitHub. So for this RPS tutorial, I will be using a Jupyter Notebook to implement the game, but like I said, there is a Python file that you can download via GitHub and execute it on your own. So let's get started and create a Jupyter Notebook. Alright, so for this, right now it's called Untitled, but we could just RPS game just for you to know. Save it wherever you want. So for this first part, we will be importing the libraries that we want to use. Specifically, in this case, I decided we will be using time, OS, and random. Time will be used for dramatic effect when the computer is making a move or when the game is over. OS is used to determine the operating system that will also give a cleaner effect on your terminal's command line interface. Lastly, random is used for generating random moves for the computer. So we're gonna put this in a try and accept clause, only because if you don't have something downloaded, we want to make sure that you know. So if everything's downloaded, it'll just give you a successfully imported. If not, it'll give you an error. So we're going to import name and system from OS, and then from time we're going to import sleep, and then from random we're going to import random int. And I'll talk more about this here in a sec. Let's run this first. Cool, nice. So now the first order of business, now that we have our libraries imported, we want to create a clear function. This will just make things look clean and neat when you run the program on your terminal. So for a basic need, we're just gonna do this. So right here, we're gonna define a function called clear. If name, so in this case the operating system name, is equal to nt, and this is for Windows, it'll run this command, system.clear screen. If the name equals post6, this is for Macs and Linux, the system will run this command, clear. Just as simple as that. We can run this right now, but it will not do anything, only because we're not running on a command line, so it doesn't do anything. That's okay. So next up, now we want to implement our game logic into a function called Rps Instructions. So this is just in case somebody forgets how to play the game and whatnot. They can print out this small menu, this logical menu, and have them review it. It's just going to contain a print statement, nothing fancy. It'll just look like this. We run that. We can call this function as well, and it should just return that, which is exactly what we want, because if a player is playing this game and they don't understand how rock paper scissors works, which I hope everybody does, it'll just give them this set of instructions, aka our logic. Okay, so now we can implement our game function, which we'll call RPS just for the sake of it. So let's start with that. So we could just do def RPS, and here we're not passing in anything. Why? Because we don't need to pass in anything. All right, cool. So now that we have this, our first order is to define our moves dictionary. So this is used to determine the name of the move for the computer and user that will then be passed into a win-loss table. So pretty basic. It'll look something like this. So moves dictionary. A dictionary contains a key and a value. Our key is 0 and it contains a value of rock. Key is 1, contains a value of paper. Key of 2 contains a value of scissors. Awesome. So next we said win-loss table. So this is a table based off of game theory and set theory that is used to understand your opponent's, in this case the computer's move, and your move to decide who wins. By doing this, we eliminate the need of multiple if-else statements. I'll have 2 links in the description for you to understand the logic behind this table. Cool video and a cool blog, very easy to understand, not hard at all. So we'll copy and paste this into here. Boom. Okay, so there's our win-loss table. Now, rock paper scissors, as we know, isn't just a one and done deal. In some cases it is, but for the sake of this tutorial, we want to be able to play more than one round and be able to exit the game when we say. So we're going to nest all this in a while loop and set it to true. This will hold everything we need to do for the rest of the game. So we can begin by doing while true. While true. Cool. So now we're gonna have another small menu, that way the users can see what they can do within the actual game. So this will be the first thing that prints every single time. So they can enter help for instructions, enter rock, paper or scissors to begin playing, enter 3 to quit. Actually, instead of enter help, let's change it to enter ins for instructions. Yeah, we'll keep it like that. Cool. So now, after our small menu, we want the user's input choice. Also, we want to convert this input to lowercase just to make things easier. And we can do this by doing the following. This. So user input equals input, and then here you can decide to put whatever you want. I decided to go with enter your move, and then we put dot lower, and this will convert the string to lower regardless of semantics. So you can do rock, or you can do rock, or you can do rock, or something like that, and it'll always return rock. Which is good. That's exactly what we want. Depending on the user's input, we have 6 different things to cover in our logic flow. Help, in this case we changed it to instructions. Exit, rock, paper, scissors to play the game, or wrong choice. So let's implement these things. So if user input is equal to our first thing we want to do. If user input is equal to, in this case we decided to put instructions, we can change this to inst. We're going to implement the clear function, so this will clear the screen, in this case clear your terminal, and then we're going to print out the RPS instructions, which is this right here. Okay, and we're going to continue because depending on that we just move on to the next statement. So the next statement is, if we'll do an elif user input equals to 3. In this case you see how 3 is a string and not an integer, only because I decided not to convert these things into an integer value. So if the user is deciding to hit 3 to quit, we're going to implement the clear function, and then we're just going to break out of this loop. That's it. And the next one would be elif user input. In this case the other inputs that we're going to deal with is their move. So elif user input is equal to rock. We said lowercase, so everything will be lowercase. We're going to set the user move equal to 0, only because that's what we decided up here in our moves dictionary. Make sure you understand that logic. Elif user input is equal to scissors. We can put the user move equal to 2. Elif user input equals, what is it? Rock paper. We set the user move equal to 1. Awesome. And our last logic for this would be else. We're going to clear the screen. We're going to print a warning saying, oh, wrong choice, buddy, or something. Up to you. Doesn't have to be buddy, but you just want to let the user that they pressed something that wasn't an option, and then you're going to call RPS Instructions and then continue again. So this will just reloop. This will just reloop. If any of these are not chosen, this happens and it will reloop and go again right here. So cool. So now that we have that, we can work on the computer's move. We will use our time and random library from mentioned above. So we can just do computer move so you know where we are now. Okay, so we want to print and let the user know that, okay, if they chose rock, paper, or scissors from any of this, it's good, it's the computer's turn. So computer making a move, and this is fast, so we're gonna just delay 1 second so the computer thinks. So computer making a move, add some suspense to it, and then we're gonna do print, oh no, not print, sorry, we're gonna do sleep for 1 second, and then we're gonna do, so as before, as I said, when we're using random, so once the 2 seconds are up, we set the computer move to a random value of 0, 1, or 2. This contains rock, paper, or scissors. This will be done using a randit function from the random module. So this means that 0, 1, or 2 is chosen at random. So if you lose, it was random, not your fault. So we could do computer, we'll do comp move equals randint between 0 and 2 inclusive. And then after that, we want to let the user know what the computer chose. So we could do in an f string computer, my computer chose, and then we're going to pass this value of whatever the computer move is to the moves dictionary. This allows us to choose at random and receive the value. So we're passing in the key and getting the value. So comp move, and then from here, let us close our f string. Cool. So now that we have that, we're almost done. We want to pass both our values of user move and computer move into our win-loss table. So this is pretty easy. We can just call the next function RPS winner equals RPS win table, and we're passing in two values, the user move and the comp move. And then, so now when we decide who wins, so if user move equals RPS winner, we could just do print f right here. We'll do username, and this username is going to happen in our main function, so you don't have to worry about that, is the winner. Okay. Else if computer move, so in this case comp move equals, let me go a little bit lower, RPS winner, we can just say print print computer is the winner. And then close our print statement. Else, if there's no winner, print tie game. Cool. And then, just for a dramatic effect, we could do print to make some space, and then sleep for 2 seconds. Oh, sorry. And then we're gonna clear, and boom, that's it. Okay, so now we can shift enter. Oh, invalid. Oh, there we go. Nobody told me. Cool. So see, it works, no errors. We can run this and we'll be able to play the game right away. So enter your move. Rock. Computer making a move. Computer chose scissors. And right now it's not working because name user is not defined. As I mentioned, it will be defined in our main function. We can take it off and just put something else, like we can just do put user move to test it. So we can run it again and put rock tie game. It'll reloop right here because of this. But like I said, this clear function does not implement in a Jupyter Notebook, but it will implement in your command line or your terminal, your command prompt, I mean. So just letting you know, fair warning. We can play again, or we can just hit 3 and it'll quit. Cool. So we can just take that off. Okay, so now that we have that, we want to make our game function. We want to make our game run in the main function. We begin again by asking the username as the input. So before we begin, we want to create our main. We want to define what our main is. So we can do that by setting this. And then we want to do username equals input, as we did before in our game function. So now that we have that, we want to be able to play multiple games. Yes, as you saw in the RPS, the function, we were able to play more than one game. But in this case, we want to nest our game in a true while loop. And this will just give us more opportunity for the user to do what they want to do and exit when they want to exit or whatnot. So we're gonna make it pretty simple. We're gonna print a little menu once more inside a while. So we'll do while true. We're going to do a print. So in this case, the user can press 1 to play the game or 2 to quit. And we're going to nest all this in a try and accept clause because we want to make sure that we handle the value error since we are asking for numerical inputs. We don't want someone to put in 69 and have our program break. So we can do that by doing the following. So right here, try, this is a thing that happens first. User choice int input. So if they enter 1 or 2 and it works, cool, it'll just skip to the next statement, which will be our if and else logic statements for the game. So if they choose 1, well, they play rock, paper, scissors, and we call this function up here that we created. If they enter 2, then we break out of the while loop, and that's it. However, if they put 3, 4, they put some string or something, then it comes here. It comes into a value error. Why? Because we wrapped our input as an int value, so it's only accepting int values. So if it's not an int value, it'll clear the screen, it'll give you a warning, it'll continue and re-loop. Okay, so now, as I said, if the user choice equals 1, we want to play the game. If user choice is equal to 2, we want to quit the game and just thank them for coming. Else, we want to give them wrong choice, read instructions carefully. So now we can run this. Enter your name, Angel. Alright, let's play. Enter 1 to play rock, paper, scissors, enter 2 to quit. So to show you what I meant, we can do a string of whatever. Oh, gives you wrong choice. Uh-oh. Okay, enter your choice. Let's do some random number. We'll just do, like I said, we'll do 69. Oh, wrong choice. Read instructions carefully. Alright, enter a choice. 1 or 2. 1. Cool. Enter ints for instructions. So we put ints. Instructions for RPS. Rock beats scissors. Scissors beats paper. Paper beats rock. Okay. Now I know how to play. So enter rock, paper, scissors. Let's do scissors. Okay, computer making a move. Computer chose rock. Computer is the winner. Oh no. Okay, let's try rock this time. Oh no, yeah. Computer is the winner. Well, I don't think I'll be able to win this time. Oh yeah, look at that. 1 is the winner. Oh, ha. That reminds me that we forgot to change the input. So let's just quit the game. Let's go back up here where we changed the what is it called, where we changed the name asking. So right here, user move, we'll put user name. We'll make sure we run that again. Okay, so now enter your name. We'll do 1 to play, and we'll do paper. Oh, tie game. Reloop. Okay, we'll do rock. Nope, no, not winning anytime soon, I guess. Tie game. Oh my. There we go. Angel is the winner. Cool. And then reloops. 3 to quit. 2 to quit. Awesome. So there we go. It works, and it's pretty simple, pretty straightforward. So that's it. That's that. There's nothing more to it. So some things that you can do to improve this game for your own use would be to create a GUI for this game using tkinter or another Python library that allows you to create an interface. You can also create this type of game in JavaScript with HTML or some other programming language, C++ as well. So many other things. You can add more things to this program. You can keep track of who is winning during one game session. So implement a count of, okay, user is winning blah blah blah, computer is winning blah blah blah, and then it'll just reset each time. You can also eliminate the computer and add a second player. So if you want to play with your friend and you want to have two different moves. Instead of a computer making a move, you have another user, which would be pretty cool. You can also implement a version of rock, paper, scissors, Spock, which would just have a couple more conditional statements, and you can also create a menu that allows you to play regular rock, paper, scissors or rock, paper, scissors, Spock, and have two different menus, instructions, I mean, explaining how RPS works and how RPS, rock, paper, scissors, Spock, so RPS squared works, which would be really cool. And it's pretty much up to you. Like I said, there's plenty of ways you can go about this and have fun with it. But yeah, so these are just some things you can do to make your own version of rock, paper, scissors. Yeah, that's it. That's the end of the tutorial for this one. I hope you had fun. But like I said before, there are a couple files in the GitHub repository for you to view and download for your own use and go from there. If you would like to contribute to this project, please feel free to commit your changes on GitHub, and I'll take a look and see what's appropriate to change. If you saw anything that was wrong within my logic, please let me know, and I'll be happy to change it. There will also be 2 links provided that will help you understand what I meant about the win-loss table being implemented using game theory and set theory. So a video by William Spaniel and a tutorial by DK MathStats, who implemented something similar but in R. If you have any questions, please leave a comment, reach me on Twitter, or send me an email. If you enjoyed this project tutorial, please leave a comment and like, subscribe for more awesome videos to come, and that's it. I will see you in the next video. Dream, code, and live. See you guys.